Okay, so let's give a proof of the Brouwer fixed point theorem. Okay, so this is a good one. All right, so this says that any continuous map from the ball to itself has a fixed point. So theorem. This is the Brouwer fixed point theorem. So any continuous that is continuous has a fixed point. All right, and this is going to lead to some other interesting theorems. So this is our first fixed point theorem. Okay, so let's give the proof. Okay, so what we're going to do is we're going to produce a retraction onto the boundary, and if not, so suppose not. Okay, and so here is dn. Okay, and so I can take x, right, and then I can take gx. So here's x, and here's g of x. And then I can make a line from g of x to x, like so. Okay, and then this defines f of x. Okay, so what we do is we take f of x to be the line. So in its directed line, so it's a ray, right, from g of x to x. Okay. All right, and so this gives us a map here. So this gives us a continuous map f, right, from dn to Sn minus 1. Okay, f is continuous, right? So this is continuous, right? And you'll also note that f, so this is continuous. Also, f restricted to the boundary is the identity. That's why we chose this directedness. Okay, so it sends it back to x. Okay, so if we were to go here, it would go out and then come back in. All right, and so this is going to give a contradiction. So this gives a retract, right? So this gives and then now we're going to go back to what we did in that original video, right? So this gives so we now have the following situation. Here we have Sn minus 1. It goes into Dn as the boundary map. And then we have this map here, f, goes into Sn minus 1. And then this map here is the identity on Sn minus 1. Okay? So now we'll take, this induces a map on pi n's. So now I'm going to kind of abuse, so you can make this pointed, but or you can make it up to outer automorphism. But this induces, so after taking pi n plus 1, we apply the pi n plus 1 functor. So we get the following here. So maybe I can just finish this on one page, right? So we get pi n minus 1, Sn minus 1, pi n, so this space is contractible, pi n minus 1, Sn minus 1, right? And then this thing needs to be the identity as well. Okay? So this thing's isomorphic to z. This thing's isomorphic to z. Okay, because pi n minus 1 of Sn minus 1, whether you've seen this or not, it is z. And then this thing's trivial. Right? And then this is a contradiction. Right? So that's the proof of the Brouwer fixed point theorem using, and you really don't need to use, it doesn't matter what invariance you use really. Here we just used homotopy groups and the fact that pi n of, so what do we use, right? So we use that this is contractible. We used functorality of this, and then we used that this pi n of Sn minus 1 is equal to the integers. Okay, that's the proof of the Brouwer fixed point theorem.